Hello, my name is Shantanu Kota and I'm gonna talk about bucket sorting algorithm. In bucket sorting algorithm, the data is distributed in form of buckets, and each bucket can hold a similar amount of data. And after distributing the data in buckets, it is sorted using the sorting algorithm. After that, all elements are gathered on the main list to get them sorted. So now I'm going to show you how it works on paper.
Bucket sort. Bucket sort is an algorithm used to sort a collection of elements, provided we know the range in which these elements will occur. Let's see what the steps taken by bucket sort are using an example now. So I'm going to consider a sequence of tuples. So I'm going to have a pair of few elements like this, pair of elements. Let's say that these tuples are going to be part of our linked list. So it is going to be in this sequence. Each will point to its successor. So this is going to be my sequence of node tuples. A tuple is nothing but a pair of elements stored together. Yes. Now I want to sort these elements based on the number of given in the tuples. So what will I do? So I know the fact that these are numbers going to be in the range from 0 to 9. This is an information given to me before I start sorting. So we know that the range of the numbers is 0 to 9. So the first thing I'm going to do is create an empty array from indexes 0 to 9. So I'm creating this empty array. Now I'll have to make the indexes 0 to 9. This is going to be my array. Now I'm going to traverse the initial list one by one. First we will look at 7D. Now since the number here is 7, I'm going to create a linked list at position 7 pointing to the node 7D. Now I will go to 1C. Since the number is 1, I will create a linked list at position 1, index equal to 1, pointing equal to the node 1C. Now I'll go to 3A. At position 3, I will start the linked list. Oh, sorry, this is the third one. Now I'll go to 7G. So there's already a linked list form, so I'll add it here. 7G. I'll go to index 3. This is added over here. So as you can see, we are going to create an array of linked lists. In the beginning of them are going to be equal to none. So if it's 70, we will store it as 7, index number 7. If it is 1C, we will start at linked list at 1C. If it's 3, we will add it to the 3. This is how the first phase of bucket sort is going to happen. We are going to create this array of linked lists. Now, once we have created this array, we are going to traverse the secondary array, and every element which we encounter, we are going to add it to our new linked list. So I'm going to start at the index 0. 0 is null, so I won't add it to my linked list. There's nothing to add. Then I'll go to 1. 1 has a linked list, 1C. Then I'll go to 2. 2 doesn't have anything to add. Then I'll go to 3. 3 has linked list 3A, 3A and 3B. So this will be added to the linked list. 3A, 3B. 4, there's nothing there. 5, nothing there. 6, nothing there. Then I'll go to 7. What should I add to my linked list? 7D and 7G. With this, I would have sorted my initial list and arrived at this new list. This bucket sort is called a stable sort right now. Why is it called a stable sort? Because when you have a series of tuples and you have two tuples of the same key, that is we have both of these of 7. So we have two tuples having the same key, which we are sorting. In that case, the tuple which we encounter first in the original list will remain in the tuple we encounter in the secondary list. So 7D comes before 7G. 7 and 7 are both the numeric values of the tuple. Now when we are sorting it, we are not going to change this position. D will come before G in the initial list, and so D will come before G in the final list as well. Over here, A comes before B in the initial list, and so sorted list A will still come before B, even though the number with which we are performing our sort is equal. So what does this mean? If there is more than one tuple of the same key, the initial order of the tuple is retained. That's why we call it a stable sort. So let's look at the pseudocode we can write for the bucket sort. So I'm going to write an algorithm called bucket sort. As input, it is going to take some input sequences, range n, and it's going to take a bucket array b. So S is the sequence, then is the range, b is going to be the bucket array. So now what must we do? We need to start storing which is part of the sequence into our bucket array. So while the sequence is not empty, what I will do is, first I will take an element from the sequence. So I'm going to take off the element from the sequence, s dot remove first. And what will I get when I remove this? I'm going to get the object from the sequence. I'm going to be returned some object which is going to have a key, which is going to be a number, and it is going to have some element e. So I'm going to get a key element pair from removing the array or removing from the initial list. Once I have this key element there, what I want to do is b, which is our bucket array. So in the bucket array, at index equal to the key, I want to add this object. So to this index, I would want to add with this object, which is a key element pair. So what will I just do? I will remove this from the list. Now element is d at the index of the 7, at the index 7. So the linked list there. I'm going to add to the end 7d. So that is what we're doing over here. We will keep roaming from the initial list until the list is empty. So while this list is not empty, I want to add from the initial list into the bucket array. Let's call this whole thing phase number 1. Now let's go to the bucket array and insert into the linked list. So now we have to transfer the bucket array. To transfer the bucket array, we need to go from 0 to all the way to our range, because the bucket array will be the size of our range. So let's go for I equal to 0 and I ends at n minus 1. Now what will we do? We have to empty out each of these indexes. So while the bucket of I, or while bucket of I is not empty, so we'll take it out and store it as an object which has a key element pair is going to be p of I, and I want to remove first. Now once I have removed that element, I will add this element to the end of our sequence. Note that over here our sequence is becoming empty. So now we can start adding these elements back into the sequence which has become empty. So we say that s dot add last object, and with that we come to the end of phase 2, because we're going to do this for all buckets. So let's see how this works. I minus n. While b of I is not empty, b of I is empty here because b of 0 is empty. So we go to the next iteration. I is 1 while b of 1 is not empty. So we store 1 comma c in a variable object. Then we add 1 comma c to the end of our sequence. Once we remove 1 comma c, when we remove first, 1 is going to become empty. Then we say while b of 1 is not empty, but at this point after having removing 1 comma c, 1 is going to be empty. So we go to the next one. 2 is empty, so we go to the next index. Then we see 3. 3 is not empty, so we go to the list 3. We remove the first element. We remove 3 of a. Then we add it to the end of the list s. Now when we remove 3a, we go and check whether b of 3 is empty. B of 3 is still not empty because 3 comma b is still there. So 3 comma b still exists. So we remove this from that and we add it to the end. Now 3b of it has become empty, and we go to the next one. This is how you keep going through the different indexes and create the sequence once again. So this is how bucket sort works, and this is the algorithm for it. This is going to be phase 2. And with this we can return our sequence. And we can end our function. So let's see how much time of this takes. So phase 1 is going to be order of what? It is going to be order of all elements of S. So what are the number of elements of S? Let's say the number of elements of S is n. Now let's see phase 2. Phase 2 will occur how many times? It will occur n times, which is the number of elements in our range. So phase 2 is going to be order of capital N. This is going to be the number of tuples. And phase 2 is going to be our range. So totally the bucket sort is going to take how much time? It's going to take the first phase time plus the time taken for the second phase, which is small n plus big N. So this is bucket sort. This is how we write the algorithm for it, and this is how we can determine the big O of bucket sort. Thank you.